Hello everyone, and welcome to this week's episode of Fitness Lit Breakdown. I'm your host, Dr. Nick Truby. I want to thank you first and foremost for tagging along for the next 40 minutes or so, as that tends to be where I average the past few episodes. And also for all of your support these past few weeks. I'm diving in today in an extension from episode 1 when we chatted about should you or should you not train to failure, speaking specifically to resistance training exercise. And if you recall, we basically found out that yes, you can improve strength measures and some increases in muscle size based on lifting to failure compared to not lifting to failure. But it wasn't that big of a difference, especially for the layperson or the average Joe walking around. The additional effort that was being required, the additional risk you might be taking, the additional time it takes for recovery, probably not likely worth the additional effort that you would see in results compared to not lifting to failure. Now I've got an interesting study here today that dives into looking specifically at strength and improvements in size, depending on if you're lifting a high load or a lower load, and I'll dive into specifically what those are, but still lifting to kind of essentially failure in either situation. So if this is your thing where you like to get that muscle pump, or you're really working and kind of getting to that momentary feeling of fatigue at the end of at each set, this is something that's going to be really interesting to you. So before we dive in, if by the end of this, if you feel inclined to leave a review or a comment or a suggestion for a future week's episode, feel free to do that. I so much appreciate your support in this as well, because the obvious goal is to bring this to as many people as possible so that the tools we discuss and working to apply these into your everyday life and training can get out to as many people as possible. So thank you again. All right, so let's dive in. We're talking about specifically strength and hypertrophy adaptations between low versus high resistance training. So real quickly again, we talked about these before in episode 1. Strength, the typical or normal definition of what strength is defined as your 1 repetition maximum. So how much weight can you lift one time of a specific exercise? Hypertrophy is just kind of the scientific name for improvements in muscle size. And we're talking about the actual muscle fiber of a muscle and all the muscle fibers within that muscle improving or increasing in size, not actually getting more muscle fibers. Okay, so hypertrophy is improving or increasing the muscle size, not more muscle fibers. Now we're looking at specifically with high versus low load training, the biggest, I guess, the way in which we were comparing these two when we dive into this. This was also a systematic review and a meta-analysis. So we won't dive into what those mean as much as we did on episode 1 where we talked about all the differences between the two, but essentially the investigators of this study did not take actual subjects into their laboratory setting and test them. They looked at all of the data that has been done previously, pulled it together to get a very strong showing of things we can assess and predict and take away from all of these if we look at them through one microscope. So really looking at the difference between if you're lifting less than 60% of your 1 repetition maximum or more than 60% of your 1 repetition maximum. That was considered low versus high. Okay, so keep that in mind as we jump forward here. All right, so let's dive into kind of what's been looked at and said previously, because this will help you kind of understand all of the dynamics and methodology behind what we're looking at. When you look at most of current knowledge on resistance training, most experts will say, just kind of on a generic baseline level, that if you're working at greater than 70% of your 1 repetition maximum, that is likely your best avenue for improving muscular strength and muscular size. So 70% and greater, usually around 70% of your 1 repetition maximum, you're doing somewhere around 12 repetitions of that movement. Okay, so if you're kind of basing this on effort, that gives you, if you're matching the resistance and you're really challenging that resistance, you can do it 12 times and you basically get to almost a failure type situation, but you're still maintaining technique, which is always important in my point of view. That's usually around 70% of 1 rep max. So anything that or greater usually is kind of the number saying this is your best bet for improving muscle size and strength. Now, when you look at defining that more, in a smaller scope, usually when you talk about pure strength, repetition ranges of 1 to 5 have really been shown to improve strength. If you're looking just specifically at repetitions, matching that with a certain intensity, aka resistance, reps of 1 to 5 of your 1 repetition maximum have shown to improve strength. When you look at gaining muscle size, it has been shown to be best achieved in a repetition range of 6 to 12, which is, typically anywhere between that 70 to 85-ish% of your 1 repetition maximum. You can expect that. So thinking that in that context, that's where most of the literature, and even how we teach it in most of the methodological study classes of strength and conditioning in a university setting, we kind of hint to those variables. But we need to understand what is going on in the physiology that promotes these different types of improvements, and how from a neurological or a neuromuscular standpoint, what is actually occurring to allow you to lift that load that many times before we start to see actual fatigue take place. Okay, so most of when we think about producing force in the muscle, it's all geared towards what's called the size principle. And I think I touched on this earlier, but I'll go over it again because it's very important. The size principle basically says, and it's always geared towards efficiency and using the least amount of energy possible from a full body energy standpoint, that when you start to produce force within the muscle to lift something or move something or push or whatever kind of activity we're talking about, we always begin neurologically, neuromuscularly, by recruiting the smallest muscle fibers, which tend to be those type 1, which don't produce as much force, which tend to be much more aerobic in nature, taking longer to fatigue. They're much smaller in diameter, meaning they don't take as great of an energetic or signal to actually say, hey, muscle, turn on and do something, okay? Those tend to be recruited first. Now, as the need to produce more force happens, we start to recruit more and more and more type 1 muscle fibers. If force is still needed to be increased, then we start to recruit those larger muscle fibers. And those tend to be your type 2 muscle fibers, which are larger in diameter, which produce more force, which if you fast twitch, right, those are your fast twitch muscle fibers, but they also fatigue much faster as well, okay? So there's always that interplay between I can produce small amounts of force, but I can produce it for longer periods of time, right? Because those type 1 aerobic slow twitch muscle fibers are mainly involved. If I need to produce more force, I'm recruiting all of those type 1 muscle fibers because I'm kind of ramping up how much force I'm producing within the muscle. But then I have to start recruiting those type 2, the ones that produce more force but fatigue faster. So that's why when you think of it just at a basic pure physiology level, you can't lift or push or do whatever at that high intensity, that high load, as long as you think you might like to, because you start to fatigue those higher force producing muscle fibers. So therefore you have to rest to recover those muscle fibers. Now, when you look at that, at the size principle, it basically says you're going to recruit those type 1, those smaller muscle fibers first. I'm going to continue to ramp up, turn that dial up as I'm recruiting those, and I continue to recruit those and then recruit larger and faster twitch muscle fibers and just keep going up and up and up the spectrum until I recruit as much as I possibly can, and that's basically the max amount of force I can produce, okay? Now, when you look at it from a pure ability standpoint, most research points to at around 30, maybe 40%. 40% might be pushing it, but about 30% of your 1 repetition maximum. That is the threshold to where all of those type 1 aerobic type muscle fibers that don't produce a lot of force, all of those are recruited within a given muscle. So if I have you seated on a chair and I hook your leg up, your ankle up to a machine, and I want you to extend your knee, right? Straighten your leg to assess the strength of your quad. If we put 30% of what you're able to do one time on there, we're basically saying we're recruiting all of the type 1 lower tier force producing muscle fibers to produce this amount of force. And obviously you could probably do that many times before you fatigue. Now, if I put more and more and more weight on there, obviously it's going to require more effort, more signal from the brain to the muscle to recruit more muscle, and higher muscle and larger muscles to produce that amount of force. And that's when we start to see faster rates of fatigue, okay? So when you look at it from a pure electrical standpoint, we can measure this through a real cool tool called electromyography, EMG, you may have heard. And most studies in the exercise world are done with surface EMG, meaning there's a little sticker with an electrode we put on your skin, basically kind of like a Band-Aid, and it's hooked to a wire and to a computer that gives us the output or the electrical signal that we're picking up in the approximate area of that muscle we've selected. And it gives us a nice big spike on a graph if we're looking at it through our computer software system, which is cool. And we can basically see the amount of that muscle as a whole, how much is being recruited based off the height, the amount of spike we see in the output reading. Okay, I don't want to get overly scientific with this, but that gives you a pretty good idea of what's going on. And these are called amplitudes. Amplitude is like the height of that mountain we see on the chart. When you look at older studies, we've usually seen that the EMG reading, if it's less than 50% of your 1 repetition maximum, we see lower peaks, right? We're not recruiting as much muscle. We sum all those electrical signals together, put them on that one peak on the graph. It's a smaller mountain. When it's above 70%, we see a much larger increase in the electrical activity occurring within the muscle, meaning we're recruiting more amount of muscle, basically, okay? Now there's some inherent flaw with this because we're not actually seeing the precise muscle because we're picking up all the electrical activity in the area. So we might be picking up, muscles in close proximity. We might be picking up, different amounts of nerve firing around that area as well that all kind of get sumped and clumped together to produce that mountain or that curve. So there are some inherent flaws with this. We can get more technical if we want to do a little bit more invasive procedure, which they have those, and you kind of stick that electrode actually within the muscle cell itself. So most of the studies don't go that far involved. Now we've seen differences between 50 and 70%, basically recruiting more muscle at 70%, which hopefully means we're getting stronger, right? That's the goal. We've also seen kind of the opposite of that when we looked at other studies that show either it's a high resistance or low resistance. We're still seeing a similar amount of muscle recruitment based on that EMG signal, that big mountain that we're seeing on our computer output, okay? So there's a lot of discrepancy there, and it could be due to many things when you think about just the inherent flaws of the system like I talked about before. But there are other things such as rate coding, and that deals with the firing frequency of the muscle. Now, all I'm talking about there is anytime a muscle is recruited, the brain sends a signal through that specific motor neuron, aka the nerve, to the muscle, and it says you need to actually do something, you need to contract. Now, when you look at the frequency, we put those little, those stimulations, those signals together, very closely together for a longer period of time, which sends that signal to the muscle saying, you need to do this action, right? It's not just a twitch, it's an actual pure, novel action of the muscle itself. So depending on that firing frequency, sometimes that can be a challenge to pick up via the surface electrode, right? It could also be that we're looking at the synchronization of those motor units, meaning how and the organization in which we're recruiting certain parts of that muscle, okay? That can change the output as well. It might not give us a pure vision of what we're looking at. So other things along with that we don't need to dive into because it can be quite the rabbit hole of fun in my opinion, but just knowing in general that it's a great tool to look at if we're looking at trying to understand how much muscle is being recruited, but there are some inherent flaws to it, okay? And there's another really interesting part too, which I love to look at when you talk about fatigue, is called motor unit cycling. So a motor unit is the motor nerve, the actual nerve from the brain to the muscle, and all the muscle fibers that it actually talks to, or innervates is the term that's used. And when you think about just like your quad, for example, you bringing up and extending your leg to make it straight, depending on the amount of force that you need, other parts in specific areas of that muscle might fatigue compared to the other, right? If you're doing, something like 80% of your 1 rep max during that exercise, you're going to start to see fatigue, where parts of that muscle will be recruited and de-recruited depending on if that part of the muscle is fatigued, the other part is not as much fatigued. It can take on the load for a fraction of a second until it fatigues. Then it switches on and goes to another part of the muscle until it fatigues. So a lot of times it picks up and they call it recruits and de-recruits areas of the muscle, depending on if it's fatigued or if it still has a little bit of juice left in the tank, basically. So all these things are challenged to pick up, basically meaning there's a lot of discrepancy in that surface EMG way to measure muscle activity. So this study kind of got away from that a little bit, and it wanted to look more so at pure, actual, objective amounts of weight. We're not going to use all the EMG stuff because we know the inherent flaws. We're going to say it's either X percentage of run rep max. In this case, the training load was equal to or less than 60% of your 1 rep max, which means you were training at low load training. And if it was greater than 60% of your 1 rep max, you were considered high load training. And this kind of extends and continues this ongoing research. And this to date was probably the largest one that looked at in terms of overall studies that they could combine together to get a really good picture of what's going on between high training loads and low training loads specific to strength and muscle size. All right, so let's keep that in mind. And through all of their research that they conducted, they looked at, similar to what we talked about last time, thousands of investigations pop up when you use these databases, and you have to be very specific to what you're looking at. It could be to training protocols, it could be to methodologies of how they were measuring these protocols, it could be to populations in specific, training outcomes, all these things. So they got very narrowed picture and really kind of honed in on what they were looking for. So when they looked at these as well, they also looked at specific changes to muscle mass, aka muscle size, right, hypertrophy. And they had to be a minimum of at least 6 weeks. So longer training studies were of importance here. And one of the key parts to this is they only included longitudinal studies, which those are kind of the sweet spot, the ones that give us the most details on what actually changes in a person. Longitudinal meaning if I took you personally and I took you through 12 weeks of a training program, I would do a pre-test to see where you were at the start, likely assess you during the middle, and assess you again at the end to see what actually happened within yourself based on the training protocol I took you through. And if we can do a large group of that, we get a pretty good idea of what happens to an actual person compared to a cross-sectional study, which looks at different groups of people. I would take group A from Texas and group B from Ohio and group C from California, and obviously their training protocols would be exactly the same, and we're comparing apples to oranges, but sometimes we can get a good idea of what's going on in that cross-sectional text, but not as well of an idea from longitudinal studies. So this is they really only looked at very high-level studies with very specific training outcomes, and they were all longitudinal. So great stuff that they looked at, and that's really important to keep in mind. All right, so of that, they found 21 studies that were meeting their demand and integrity and rigor of this study. And they also had a wide range of ages too, which I think is great because that allows us to extrapolate this to a wider population other than what they just looked at in the studies. So we can kind of extrapolate this to a much greater population, which I think is important because we can all have some great takeaway messages that we'll talk about later on in this chat. So they had anywhere between 18 to older than 65 years old. So a great age range here. A lot of differences in training. They had untrained people, they had trained people. Some really cool takeaway messages we'll look at between the two there as well. And they had a lot of means and really good means of assessing actual outcome measures. So if they were looking at muscle size, they used MRI, they used ultrasound, they used some really great measures of other ways to measure percent body fat that could be done in a lab-based setting that are very repeatable and accurate as well. There were even some studies that did muscle biopsies, which is cool to think about, but basically they take a big chunk of muscle out of most of the time your leg, and they look at it under a microscope and they can actually measure the change in size of these muscle fibers, which is pretty cool too. So some great objective measures of muscle size. And they looked at different ways of assessing strength as well, because this is important because there's more ways to define strength. It could be like the generic way we talked about before in 1 repetition maximum. That's kind of just the umbrella of defining strength. It could be strength through a overall range of motion. So isokinetic is the term used for that, where you're assessing how much force you're producing through an entire range or a specific range of motion of a certain joint. And that has a lot to say too with things like rehab and coming back from an injury, or just looking at very fine-tuned points in a muscle's ability and how that relates to a sport or an occupation or whatever that might be. And they looked at other things like isometric strength, like you holding a plank or a wall sit or a posture. Those things are important as well. They looked at other types of strength just besides that 1 repetition maximum. And we can take some really great takeaway messages from that as well that we can move forward with and use in our own training, which I think is awesome. All right, so the statistics they did, I'm not expecting you to have a master's in statistics here, but I'll kind of break it down to where it makes sense for the study. So since we didn't have actual subjects, we can't do some typical types of statistics that compare like, you and a group of 10 people from pre and post testing. What they looked at was more specific to what's called effect size, EFFECT size. And effect size really speaks to, basically the statistics that you run, it gives you a number. And that number is a measurement of the strength of a relationship. So the relationship in this text of our study that we're diving into here was the relationship between were you lifting a light load or a heavy load, and how did that actually relate to you improving muscle strength or muscle size. And based on that strength of a relationship between these variables, you kind of get a number. And that number is usually, it's not huge, okay? I'll give you some reference points. If the number that you get after that calculation is 0.2 or less, it's usually meaning that there's a small relationship. Like the difference between these two variables is not very big. So not a huge relationship. 0.5, hovering around that 0.5 number, plus or minus, a tenth, is going to be considered a medium kind of relationship. And anything greater than 0.8 is a large relationship showing based off effect size. So if it's 0.8 or greater, that means we're seeing a really great relationship between, hey, if you lifted at a heavy load and compared to a light load, that showed better results in strength and muscle size, then we've got something here, okay? Actually providing us real objective numbers and data that say, this is something of importance and really is, generalizable to a greater population most of the time. So we'll talk about that here in a second when we get into some of the actual results, okay, which I'm going to talk about now, because I think that's the most important part. We kind of have a better grasp of the physiology underlying some of the neuromuscular things, right? You're going to recruit minimal amount of muscle depending on the force, and once you need more force, you're going to get more and more and more muscle. That's just our bodies working towards being efficient and not wasting energy if we don't have to. But now we need to see, is there an actual difference when we think about how am I going to apply my training? How much do I actually want to put forth in terms of effort or resistance or however we want to define that, okay? Now, when you look at some of the strength measures, there was two in specifically looked at and found some pretty cool data. The first one was looking at that 1 repetition maximum, all right? And they saw an effect size of 1.3 for the low training load and 1.6 for the high training load. So both said, whoa, right? There's some serious relationship here between my training load and the effect I'm seeing in my 1 repetition maximum. And they saw a percent change, and they were both improvements from pre and post of 28% in the low load and 35% in the high load. So right away we're seeing that, yes, if you trained at a higher load, if you were training at a greater than 60% of your 1 repetition maximum to failure, right, to momentary failure of that actual set, over time with those 8, 10, 12-week studies, we saw a greater improvement in your ability to produce force or your strength, right, 1 repetition maximum. So there was a difference there. But if you look kind of nitty-gritty into the details, that's not really a huge difference. Okay, so even if you lifted at less than 60% of your 1 rep max, which is usually like maybe a 15 repetitions you can expect out of that exercise, we saw a 28% improvement in 1 repetition maximum. That's huge, okay? Now, if you want to work at a higher intensity, aka more weight, then we're seeing a 35%. So not a huge difference between the two. It was seen statistically different, but from my vantage point, if I'm working with a typical client, I'm worried about things like technique, right? The more you load a movement, the more challenging overall technique becomes, the more flaws you start to see in movement patterns. All those things that could be seen as a negative start to creep into the picture. Compared to working at a lower resistance, I really have much more focus and ability to maintain posture, maintain overall exercise technique. Even though I'm still lifting to failure, the overall load has a huge difference in that, okay? So we're seeing improvements in strength no matter what. Bottom line, great takeaway message. When you looked at isometric strength, that's when isometric means basically no movement. So the muscle is contracting to hold your body in a specific movement, like a wall sit or a plank, or you holding a bicep curl with your elbows at 90 degrees and just kind of seeing how long you can hold it for. That's isometric. We basically didn't see any difference between if you trained at a high intensity or low intensity, right? Greater than 60% or less than 60% of your 1 rep max in isometric strength. So that's pretty cool right then, knowing that I don't have to worry about higher loads to still see improvements, the same amount of improvements as lifting at a higher load. All right, so that's pretty novel right there. When we looked at hypertrophy, there was a slight difference in effect size, and it was kind of a medium effect size, showing that high versus low, we saw improvements, and the difference was a 7% improvement or percent gain in muscle size compared to an 8.3% low versus high. So if you were lifting at that higher load, you saw a 1% better improvement in overall muscle size. That 1% was not shown to be statistically significant, and you probably wouldn't notice it at all if you looked at a person and saw 1% improvement compared to another group, right? So that is a great takeaway message there as well, especially if you're more of a beginner type exerciser and you're worried about, like I mentioned before, working on improving your exercise technique, working on your form, working on these movement patterns that are going to set you up for success down the road. A lighter load, I think, can help you get there, right? Because yes, we're training to failure in both situations, but you fail much faster at a higher load, right? If I gave you 90% of your 1 repetition maximum, you'd likely fail within 3 or 4 reps. So you've only practiced great technique for 2 reps. Compared to at 60% of your 1 rep max, I could basically say you can practice sound technique for probably 12 repetitions and then just be challenged, more so on before you fatigue those last 3 repetitions. So I'm more of a fan of that at a lower load, especially for beginners, because you can work more on movement patterns and not focus on just, hey, can I lift this amount of weight? Okay, so hopefully that makes sense, and that's a great takeaway message for your training as well. So yes, 1 repetition maximum strength was improved, statistically different than low training, high versus low, but it still wasn't a huge difference to say, hey, everybody needs to go out and do high load training, okay? The difference was substantial statistically, but not substantial enough for me to start making crazy changes to my training programs and how I train clients. All right, so when you look at some of these information and data, hopefully we're starting to see some patterns here. And the patterns I'm hoping that you're starting to pick up on are based more so on how you're thinking about changing or evolving your training. And I want you to think about, obviously, these studies they were looking at were specific to if you were a high load group, you did that high load for, let's just say, 10 or 12 weeks. If you're a low load group, you did that low load for 10 to 12 weeks, right? There was no kind of interplay between the two. Now, when I look at programming and training clients in the real world, most of the time, I'm going to create a well-rounded type of scenario where I'm challenging them at specific time points with a higher load when I feel like they're ready, and I progress them to a specific point to get to a higher load, because I do want to see overall improvements in just top tier strength. But at the same time, I have to think about recoverability, right? I've got to think about what's going to happen in between training sessions, how long it's going to take to recover. I also have to think about, is the additional effort, is the additional flaws in exercise technique that could happen, are those outweighing the worth that I'm going to say do a lot heavy training all the time compared to light training, right? So when you look at those together, we're really starting to see that most training programs should probably incorporate both, okay? And just kind of average Joe, the person that's just kind of walking around worried about their fitness, wanting to mix their training programs up, keep it variable, always work towards improvement. That's a great way to introduce some variation into training just by changing the training intensity and having to change nothing with movement patterns. Okay, so you could do the exact same 10 exercises and vary the amount of intensity you're doing just with weight and resistance, and that could essentially progress you, further into a certain extent. So also these data, it's important to note, I don't want to forget to say this, a majority of these data that were saying that were based on untrained individuals. So untrained in these settings of science in this context typically means this person hasn't been doing a structured exercise program for usually more than 3 or 6 months. So anything less than that, and you've kind of been on and off, right? You're not going like 3 weeks, 3 times per week religiously for 6 months or a year. It's kind of, sporadic. It might not be super structured. You might still be active outside of that, but not as structured and working towards improving and working on movement patterns and things like that. So that's where we saw the biggest we should probably incorporate both the high and low training volume, probably err more so on the lower training volume and work towards progressing with repetitions before introducing more weight. When you look at more of a trained status, this is where we start to see that difference kind of diverge a little bit larger. So a person that is more trained, that has gone through years of training of specific movements, of going through different adaptations of that movement, different progressions, using different variable amounts of weight with that. Now we start to see a divergence of, if I want to improve top tier strength, I have to actually lift at a higher resistance. So it really kind of goes back to specificity, meaning that if I want to improve my overall top tier 1 repetition maximum strength, I have to lift at a closer percentage of that, if not at that more frequently. And that's more so aligned with a trained person because they've made adaptations to handle that kind of stressor and recover from that stressor at a much faster rate compared to a person that's untrained, based on they don't have the foundation of fitness, they don't have the foundation of movement patterns and technique, and they don't have the ability to recover as fast as the person that has been through those adaptations before. So a more trained person would likely see improvements in strength if they lifted to failure at a higher percentage of their 1 rep max, whereas a more trained person, if you put them through a protocol of lifting still to failure, but at less than 60% of their 1 rep max, they wouldn't see as great of improvement. Okay, so hopefully that highlight, if you are, borderline, or if you're trained or untrained, you start to see some discrepancies there if you're looking specifically at improving your 1 repetition maximum or overall strength. Okay, so hopefully that makes sense there. So this could also be as specific to, as well, going back to how we started the conversation with the neuromuscular component. Right, so some people are naturally, kind of going back to who are your parents, you are naturally gifted with more of those type 2 fibers, which means you have likely will increase muscle mass to a greater extent compared to a person, could be the same size, that has a higher proportion of type 1 muscle fibers, which they still improve, they don't get as large as type 2 muscle fibers. So genetics has a component obviously in this as well, as it always does with things that relate to exercise and adaptations from exercise. So that is just something we can't totally control, but we can always control our behavior around it and how we apply these different tools. So I would say bottom line, if we're looking at this, we know strength can see differences. Yes, statistical differences, but not actual, I think, real world application for the average Joe, like, you and me maybe walking around. The additional stress we're putting on if we're doing it over time, right? I see it being used more so on the occasional basis throughout the month of a training period, right? Compared to every day or every day of the week that we're training. I see it very valuable to mix and match, add variation with load and resistance and intensity based on certain movements that you're doing throughout the week, okay? So I think for the golden nugget takeaway message, I would incorporate both. Only if you are comfortable and confident with your exercise technique and likely having someone there guiding you doing these things. Unless you are an expert and you're listening in and you feel confident and comfortable with this, then go for it. But if you're a beginner looking at improving, I would still say hiring someone that can have some say or effect in improving your technique and ability to understand these topics better, then I think that's a great route as well. All right, so hopefully you enjoyed this and got some great information from it. Yes, you can improve strength. Yes, you can improve muscle size if you're lifting at a lower load, but still to failure, okay? Or you can revert back to episode 1 and understand a little bit more in depth at looking at maybe training at a little bit higher percentage, but still not considered heavy, and how that can affect your overall strength and muscle size as well. So 2 really great studies that we dove into that give us great understanding of looking at specific ways to improve our strength and muscle size through just slight variations in how we're going to train ourselves. Thank you again for all of your interest in all things science and exercise. And if you would so kindly jump back on, give it a 5-star rating, drop a comment or review. I would so much appreciate it, as that will allow this podcast to kind of rise in the ranks of all of the other fitness podcasts that are out there for your consumption. So thank you again, and I'll be back next week with another exciting episode.